Okay, now let's look at this one here. In triangle ABC, the measure of angle A is 80 degrees. The angle bisector, okay, angle bisector bisects one angle into two equal smaller angles. So the angle bisectors, as there, of angle ABC and angle ACB intersect at point D. So what is the measure of angle BDC? So for questions like this, if we do not draw a graph there, you really cannot see how the angles are related. So draw a graph. It doesn't need to be fancy, just to help you to find how angles are related in this case. All right, I'm going to draw one that really doesn't need to be fancy, okay? So even it doesn't even need to be accurate because you don't know the answer yet, right? So I'm going to draw anything here. Yeah, something like that. Okay, something like this, okay? Something, okay, here we go. So then I name the uh, triangle as ABC. That's A. Okay, this is B, and this is C. So we're given that angle A is 80 degrees. That's given to us, right? We're also given that we're going to bisect angle ABC. We're going to bisect this angle. This angle here is angle B. Okay, bisect means you cut angle into two equal parts. Okay, so I try, all right, here we go. Two equal parts. And angle C also will be cut into two equal parts. So these two, you call them the red segments, are angle bisectors. Now, what does that mean? Okay, what matters is that these two angles are congruent. Okay, and then these two angles are also congruent. That's what angle bisectors mean. And then these two angle bisectors, they cross each other at the point D. We want to find the measure of angle BDC right here. What's the measure of this angle? Again, we will use the property of a triangle. That is, the interior angles in a triangle add up to be 180 degrees. So that means, okay, so I'm not going to use a measure here, right? Just angle A plus angle ABC. That's angle B rated, right? Angle ABC. Plus, you said, Mr. Smith, can we use measure there? M there. You don't want to, it's fine. Okay, plus angle ACB. Okay, that's equal to 180 degrees. Okay, that's a property for any triangle. We're given that angle A is 80 degrees, right? So that's 80 degrees. So now, if we subtract 80 degrees from both sides of the equation, we know that the sum of angle ABC and ACB is 100 degrees. Okay, here we go. Now, this angle ABC is divided into two equal smaller angles. Make sense? So that case, this angle is half of angle ABC. Makes sense. I'll use a different color here. Okay. This angle is half because that's what angle bisectors do. That's also half of angle ACB. Okay, so we're going to take half of both sides of the equation, half of angle ABC, half of angle ACB, of course, half of 100 degrees. So this angle, okay, plus this angle, I name this angle as angle 1. And this, okay, plus this angle, angle 2. I'm going to trace this triangle a little thicker there so we could see better. Okay, I'm talking about this triangle now. Okay, so angle 1 and angle 2, each one of them is half. Angle 1 is half of angle ABC. Angle 2 is half of angle ACB. Okay, so then we know that angle 1 plus angle 2 should be 50 degrees because 100 divided by 2, that's okay, 50 degrees. So this angle 1 plus angle 2 is 50 degrees. Now let's use the property of a triangle again. Okay, so angle 1, okay, well, now let's look at this triangle there. Let's look at in triangle BDC, this triangle now. Okay, so angle 1 plus angle 2 plus angle BDC. That's the angle that we need to solve for, right? BDC is again 180 degrees simply because we have a triangle there. Now we know that angle 1 plus angle 2 is right there. That's 50 degrees, right? So 50 plus 130 will be 180 degrees. So the measure of angle BDC, that's the angle we're looking for, is 180 degrees. No, sorry, it's 130 degrees.